This is the EdExcel GCSE 91 Maths Paper 1 from the November 2017 series, and it's from the higher tier, and it's a non-calculator paper. Question number 2. Kiaria is 7 years older than Jay. Martha is twice as old as Kiaria. The sum of their three ages is 77, and we have to find the ratio of Jay's age to Kiaria's age to Martha's age. Well, we will begin by letting Jay's age equal x. And if Kiaria is 7 years older than Jay, that means that k is equal to x plus 7. And if Martha is twice as old as Kiaria, that means m is equal to 2 lots of x plus 7. Now, we were told that the sum of their three ages is 77. So therefore, we've got x plus 7 plus 2 lots of x plus 7 equals 77. And if we find out what x is, that will enable us to find out J's age, k's age, and m's age. So we've got x plus 2 lots of x. That will be 4x. So we've got 4x, and then we've got 7 plus 2 lots of 7, that's 21. So we've got 4x plus 21 equals 77, and if we subtract 21 from both sides, 4x is equal to 77 take away 21, which is 56, and therefore x is equal to 56 divided by 4, which is 14. So J's age is 14, k's age is 14 plus 7, which is 21, and m's age is twice of 21, which is 42. And now we can find out the ratio between their ages. So therefore, the ratio of J to k to m is equal to 14 to 21 to 42. And we can simplify this ratio by dividing each term by 7. So we will divide each term by 7, leaving us with, well, 14 divided by 7, that's 2. 21 divided by 7, that's 3. 42 divided by 7, that's 6. So therefore, the ratio of their ages is 2 to 3 to 6. Question number 3. ABCD is a parallelogram. That's what we see here. And EDC is a straight line. F is the point on AD such that BFE is a straight line. We're also given that the angle EFD is 35 degrees and the angle DCB is 75 degrees. We have to show that the angle ABF, which is this angle here, is 70 degrees. We have to give a reason for each stage of our working. Well, first of all, you can see that the angle EDF, which is this angle here, is equal to 75 degrees. So this angle here is 75 degrees. The reason for that is we have corresponding angles, so this angle is equal to this angle. Let's just write that down. So EDF is 75 degrees because we have corresponding angles. Now with this, we can actually find out what this angle here is. Of course, angles in a triangle sum to 180. So this angle here, the angle DEF, is equal to 180, take away 35, take away 75, which is equal to 70. So we have 70 degrees here. So the angle DEF is equal to 180 minus the 35 minus the 75, which is 70 degrees, because angles in a triangle sum to 180. We can also find out what this angle AFB is. We can recognize that we have vertically opposite angles. So this angle here is 35 degrees because it's vertically opposite the angle EFD. So AFB is equal to 35 degrees because we've got vertically opposite angles. Now FDC, that is this angle here, is equal to 180 take away 75, which is 105. So this angle is 105 degrees. The reason for that is we have co-interior angles which sum to give 180. So this angle is 105 because we've got 180 take away 75, which is 105. Let's just write that down. So we've got FDC, which is equal to 180 take away 75, which is 105, and that's because co-interior angles sum to 180. And this angle here is equal to 180 take away the 105, which is 75, again for the same reason. Co-interior angles sum to 180. So let's just write that down. So BAF is equal to 180 take away 105, which is 75, and that's because co-interior angles sum to 180 degrees. And the angle we're finding is this angle here, ABF, which is 180 take away 75, take away the 35, which is 70. And the reason for this is angles in a triangle sum to 180. So ABF is equal to 180 take away 75 take away 35, which is 70 degrees, because angles in a triangle sum to 180, and hence we've shown that angle ABF is 70 degrees. Question number 4. The diagram shows a logo made from 3 circles. That's what we see here. Each circle has a centre O, and Daisy says that exactly 1/3 of the logo is shaded. Is Daisy correct? You must show your working. Well, here we've got a small circle, a medium circle, and a larger circle. We can find out the area of each of those, and from that we can find out the shaded area, and then find out the proportion of the logo which is shaded. So if we find out the area of the small circle, the small circle has area pi r squared, so we've got pi lots of 4 squared, which is 16 pi. For the medium circle, the area is pi multiplied by the radius squared. Well, here the radius will be 4 plus 3, which is 7. So we've got the medium circle having an area of pi lots of 7 squared, which is 49 pi. And for the large circle, the radius here is 4 plus 3 plus 3, which is 10. So the large circle has area pi lots of 10 squared, which is 100 pi. So the shaded area, this is equal to the area of the medium circle take away the area of the small circle. So we've got the shaded area, which is equal to 49 pi take away 16 pi. It turns out here we get 33 pi, and therefore the proportion of the logo which is shaded, well, we've got the 33 pi divided by 100 pi, and of course this equals 33 over 100, which does not equal 1/3, and therefore we can conclude that she is incorrect. Question number 5. The table shows information about the weekly earnings of 20 people who work in a shop. So we've got the weekly earnings, we've got the frequency, and for part A we have to work out an estimate for the mean of the weekly earnings. So to work out the estimate for the mean, we first of all here need to define the midpoint. So the midpoint here is 200, the midpoint here is 300, the midpoint here is 400, the midpoint here is 500, and the midpoint here is 600. We then need to work out the midpoint multiplied by the frequency. So here we've got 200 times by 1, which is 200, 300 times by 11, which is 3300, 400 times by 5, which is 2000, 500 times by 0, which is 0, and 600 times by 3, which is 1800. Now, to work out the mean x bar, this is equal to the sum of the midpoints times by the frequencies over the sum of the frequencies. So we've got 200 plus 3300 plus 2000 plus 0 plus 1800 divided by 20, because we've got 20 people in total. So if we work this out, we've got, well, on the top we've got 7300, on the bottom we've got 20, so this is equal to 365. So therefore, you can see here that the estimate for the mean is 365. And now for part B, Nadia says the mean may not be the best average to use to represent this information. Do you agree with Nadia? You must justify your answer. Well, yes, because the mean is affected by extreme outliers. Question number 6. Here is a rectangle and all measurements are in centimeters. The area of the rectangle is 48 centimeters squared, and we have to show that y is equal to 3. So here we've got a length of 2x plus 6. Here we've got a length of 5x minus 9. Here we've got a length of y. And we need to work out what y is. Well, of course, this will also be y because opposite sides of a rectangle are equal. And because opposite sides of a rectangle are equal, we can see that 2x plus 6 equals 5x minus 9. So if we attempt to solve, well, rearranging, you can see that 3x is equal to 15, and therefore x is equal to 5. And therefore, the length of the rectangle is equal to, well, if I substitute into either this or this, we've got 2 lots of 5 plus 6, so we've got 10 plus 6, which is 16. So we've got 16 centimeters for the length. The width is y. So we've got 16y equals 48, and therefore y is equal to 48 over 16, which is equal to 3. So therefore, the width of the rectangle is 3 centimeters. Question 7. Brogan needs to draw the graph of y equals x squared plus 1. Here is her graph, and we have to write down one thing that's wrong with the graph. Well, clearly, we need to make sure that we join the points with a smooth curve. So the points need to be joined with a smooth curve, not a straight line. Question number 8. We have to write these numbers in order of size. Start with the smallest number. Well, here we've got 0.246, where the 4 and the 6 are repeating. So let's just write out that number. We've got here 0.246, 46, 46, etc. Here we've got 0.246, where the 6 here is repeating. So we've got 0.246, 6, 6, etc. Here we've got the 0.246, where the 2 and the 6 are repeating. So here we've got 0.246, 246, etc. And here we've got 0.246. So what you can see is this one is the smallest. It terminates after the 6. So we've got 0.246 followed by the 0.246, 246, etc. Of course, the digit after the 6, which is the 2, is the smallest one. So here we've got 0.246, where the 2 and the 6 are repeating. And then we've got 0.246, where the 4 and the 6 are repeating. So we've got 0.246. And then we've got the 0.246, where the 6 here is repeating. Question number 9. James and Peter cycled along the same 50-kilometre route. James took 2.5 hours to cycle the 50 kilometres. Peter started to cycle 5 minutes after James started to cycle. Peter caught up with James when they had both cycled 15 kilometres. James and Peter both cycled at constant speeds. We have to work out Peter's speed. Well, of course, here we'd have to use the formula. Speed equals distance over time. Now, let's concentrate on James's speed. We've been given his distance and we've been given his time. So with this, we can find out the speed. So James's speed, this is equal to his distance, 50 kilometers, over the time, which is 2.5 hours. So here we get 20 kilometers per hour. And if we take a look at the statements mentioned over here, with this we can find out what James's time is to cycle the 15 kilometers. Of course, here we need to recognize that he's cycling with a constant speed of 20 kilometers per hour. So therefore, when we come to consider James's time to cycle the 15 kilometers, you can see here the distance is 15 and the speed will be 20. So James's time for the 15 kilometers, we've got here the distance 15 kilometers and we've got the constant speed of 20 kilometers per hour. So of course we get 3/4 of an hour. So we get 0.75 hours, which would correspond to 45 minutes. And if you're wondering how we got 45 minutes, to go from hours to minutes, we would have to multiply by 60. So how does this help us? Well, we know that Pete started to cycle 5 minutes after James started to cycle. So with this, we can find out Peter's time to cycle the 15 kilometers. So Peter's time to cycle the 15 kilometers, this is equal to 45, that's shown here. Take away this 5 from here. So we get 40 minutes. And if we convert this into hours, then we need to divide 40 by 60 to get 2/3. So we have 2/3 of an hour. So to go from 40 minutes to 2/3 of an hour, we needed to divide through by 60. So how does this help us? Well, we need to work out Peter's speed. We know his time in hours. We know the distance, that's 15 kilometers. So we can easily work out Peter's speed. So Peter's speed, that's equal to 15 over, well, here we've got 15 kilometers over 2/3 of an hour. So if we work this out, this is the same as 15 times 3 divided by 2, which is 45 over 2. So we've got 45 over 2 kilometers per hour. And if you want to write this as a decimal, this is the same as 22.5. So we've got 22.5 kilometers per hour. So we've got 22.5 kilometers per hour. Question 10. For part A, we have to write down the value of 100 to the power of a half. Well, this is the same as taking the positive square root of 100, which is 10. Now for part B, we have to find the value of 125 to the power of 2/3. Well, this is the same as raising 125 to the power of 1/3 and then squaring it. Of course, multiplying the powers gives us the 2/3. So when we raise something to the power of a third, that's the same as cube rooting. So we've got the cube root of 125, which is 5. So we've got 5 squared, which is 25. Question 11. 3 teas and 2 coffees have a total cost of £7.80. 5 teas and 4 coffees have a total cost of £14.20. We have to work out the cost of 1 tea and the cost of 1 coffee. So if we take the first statement, we've got 3t plus 2c equals 7.8, and we've also got 5 t's plus 4 coffees gives £14.20. You can see here we've got 2 unknowns and 2 equations, and therefore we can solve these equations simultaneously. So, if I call this top equation equation 1, and this second equation equation 2, well, what we can do is get the c's the same, and to do that we can multiply equation 1 by 2, and if we do that, we've got 3t times 2, which is 6t, 2c times by 2, that's 4c, and 780 times 2, that's 1560. So we've got 6t plus 4c gives 1560. We'll call this equation 3. Now, to get rid of the c's, we can do equation 3 take away equation 2. So we will do equation 3 take away equation 2. 6t take away 5t, that's just t. 4c take away 4c, that's 0c. 1560 take away 1420, that's 140. So 1t is equal to 140. And therefore, if we substitute this into either equation, for example, if we substitute into equation 1, when t equals 140, just tidy this up. We've got 3 lots of 140 plus 2c equals 780. So 3 times by 140, that's 420. So we've got 420 plus 2c equals 780. And if we subtract 420 from both sides, 2c is equal to 780, take away 420, which is 360. And now if we divide both sides by 2, you will find c to equal 180. So we have t equals £1.40 and c equals £1.80. Question number 12. The table shows information about the heights in centimetres of a group of Year 11 girls. So that's what we see here. The least height is 154, the median is 165, the lower quartile is 161, and the interquartile range is 7, and the range is 20. And for part A, we have to draw a box plot for this information. Well, what we can do first of all is, if we've been given the lower quartile and the interquartile range, from this we can find out what the upper quartile is. So, the interquartile range, that's equal to the upper quartile, take away the lower quartile. The interquartile range we've been given as 7, so we've got 7 equals upper quartile, which we don't know, take away lower quartile, which is 161. So therefore, upper quartile is equal to 7 plus 161, which is 168. And we've been given the least height, we've been given the range, so with this we can find the maximum height. So we should know that the range is equal to the maximum, take away the minimum. We've been given the range as 20, we've been given the maximum, rather we are finding the maximum. We've been given the minimum, the least height, as 154, so therefore the maximum height is 20 plus 154, which is 174. And now what we need to do is plot all of these. So, first of all, let's plot the least height, which is 154. So we got 150, and then 154 is over here. So here we've got 154 for the least. Then we've got the lower quartile, which is 161. 161 is over here. Then we've got the median, 165. That is over here. And then we've got the upper quartile, 168. That's over here. And then we've got the maximum, 174. So that goes over here. So now we need to complete our box plot. And if we complete our box plot, we join these up like so. And then we join these up. And then we also join these up as well. So here is our completed box plot. And now for part B, the box plot below shows information about the heights in centimetres of a group of Year 7 girls. That's what we see here. And we have to compare the distribution of heights of Year 7 girls with the distribution of heights of Year 11 girls. Well, what we can do is compare the median, and we can also compare the interquartile range. So let's begin by comparing the median. Of course, the median for the girls in Year 11 is higher than the median for the girls in year 7. So girls in year 11 have a higher median than girls in year 7. So therefore girls are on average taller in year 11 than in year 7. And now if we compare the interquartile ranges, the interquartile range for the girls in year 11 is smaller than the interquartile range for the girls in year 7. So girls in year 11 have a smaller interquartile range than girls in year 7. Question number 13. A factory makes 450 pies every day. The pies are chicken pies or steak pies. Each day, Milo takes a sample of 15 pies to check. The proportion of the pies in a sample that are chicken is the same as the proportion of the pies made that day that are chicken. On Milo calculated that he needed exactly 4 chicken pies in his sample. We have to work out the total number of chicken pies that were made on Monday. So what we need to notice in this question is that the proportion of pies in a sample is the same as the proportion of pies that are made. So he selects 4 chicken pies out of a sample of 15. So we've got 4 over 15, and this is the same as x, which is the number of chicken pies that were made on Monday, over the total which were made on Monday, which is 450. So these are equal because of this statement over here. Now if we find out what x is equal to 4 over 15 times by 450, which is 120. And now for the next part of the question. On Tuesday, the number of steak pies Milo needs in a sample is 6, correct to the nearest whole number. And Milo takes a pie from the 450 pies made on Tuesday. We have to work out the lower bound of the probability that the pie is a steak pie. So first of all, let's take a look at the error interval. For the error interval, we've got 5.5, which is less than or equal to p, which is pies, and then this is less than 6.5. So if we follow the same strategy as we did before, recognizing that we've got the same proportions, we can find out the number of pies made on Tuesday, which are steak. Okay, so we've got 5.5 because we're considering the lower bound over 15, and this is the same as y, which is number of steak pies, over 450. So these are equal. So we found out what y is. We've got 5.5 over 15 times by 450. So 450 divided by 15, that's 30. And then if we multiply that by 5.5, 30 times by 5.5, that's 165. And therefore for the probability, so therefore for the probability, we've got 165 over 450, which if I simplify this by dividing through by 15, we get 11 over 30. So just to emphasize, we will divide top and bottom by 15 to get this value. So we've got the probability being 11 over 30. Question 14. The ratio y plus x to y minus x is equivalent to k to 1, and we have to show that y equals x lots of k plus 1 over k minus 1. Well, given this ratio, we can express these in equivalent fraction form. We have y plus x over y minus x, which is equal to k over 1. And we need to rearrange for y. So if we cross multiply, we've got 1 lots of y plus x equals k lots of y minus x. And if we expand the brackets, we've got y plus x equals ky minus kx. And if we take everything over to one side involving a y, and everything that doesn't involve a y to the other side, we've got ky minus y equals kx plus x. And if we factorize, on the left hand side we've got y lots of k minus 1, and on the right hand side we've got x lots of k plus 1. And if we divide through by k plus 1, we can conclude y is equal to x lots of k plus 1 over k minus 1. And that's exactly what we wanted to show. Question 15, we've given that x equals 0.436 recurring, where the 3 and the 6 are repeating, and we have to prove algebraically that x can be written as 24 over 55. Well, first of all, we've been given x, which is equal to 0.436, where the 3 and the 6 are repeating, so we've got 3, 6, 3, 6, etc. And if we multiply by 100, because 2 digits are repeating, 100x is equal to 43.6363636, etc. And if we subtract these equations, you can see that 99x, this is equal to, well, we've got 43.636, etc. take away 0.43636, etc. You can hopefully see the terms here cancel out. So we've got 43.6 take away 0.4, which is 43.2. And if we divide through by 99, you can see x is equal to 43.2 divided by 99. And if we multiply through by 10, we've got 432 divided by 990. And if we divide top and bottom by 2, we get 216 over 495. So we get 24 over 55. So we get 24 over 55 as our final answer. Question 16. Y is directly proportional to the cube root of x when y is equal to 1 over 6, 1 and 1/6, x is equal to 8, and we have to find the value of y when x is 64. Well, first of all, let's convert the 1 and 1/6 into a top-heavy fraction. We've got here 6 times by 1, which is 6, plus the extra 1, that's 7. So we get 7 over 6. So let's take this statement at a time. We've got y, which is directly proportional to the cube root of x. So we've got y, proportional symbol, cube root of x, and if we rearrange, we've got y equals k lots of cube root of x. When x is equal to 8, y is equal to 1 1/6, which is 7 over 6. So we get 7 over 6 equals k lots of the cube root of 8. So we get 7 over 6 equals 2k, and if we divide through by 2, you can see k is equal to 7 over 12. And therefore, we can conclude y is equal to, if we replace the k with 7 over 12, we've got 7 times by cube root of x over 12. And now when x is equal to 64, y is equal to 7 times by cube root of 64 over 12. So we get 7 times by 4, which is 28. So we've got 28 over 12, which is 7 over 3. And if you want, you can rewrite this as 1 whole, and rather here we've got 2 wholes and a third. Question 17, n is an integer, and we have to prove algebraically that the sum of 1/2 n lots of n plus 1 and 1/2 n plus 1 lots of n plus 2 is always a square number. Well, let's find out the sum. So far, we've got 1/2 lots of n lots of n plus 1 plus 1/2 lots of n plus 1 lots of n plus 2. And if we factorize out the 1/2 and the n plus 1, because those are common to both, we've got 1/2 lots of n plus 1, and then inside this big bracket we've got n plus n plus 2. So we've got 1/2 lots of n plus 1 lots of 2n plus 2, and if I factorize out a 2 from here, we've got 1/2 n plus 1 times 2 times by n plus 1. And of course 2 lots of n plus 1 gives 2n plus 2. And then here you should spot 1/2 and the 2 cancel. So we're left with n plus 1 lots of n plus 1, which is the same as n plus 1 all squared. So n plus 1 all squared is a square number for all integers n. Question number 18. We have to enlarge shape P over here by a scale factor of -1/2 with centre of enlargement at the origin, and we have to label our shape Q. So if we consider this point, it goes through the origin. So we've got 3 down and 2 across this way. So if we multiply that by 1/2, we would have 1 across and we'd have this over here. Okay. So let's just extend this line. We've got something looking like this over here. Now, if we consider this point here, we're going 4 across and 3 up. So if I show that in the opposite direction, 4 across and 3 down, got something looking like this. And if I just simply extend this, then here we're going to have 4 across and 3 down, so we go down here somewhere. Okay? And if we consider the point as we see here, you can see here we are going 2 across and 7 up. So in the opposite direction, we've also got the same thing as well. So let's correct this. Got this situation. And if I just correct this as well, that was 2 across and 3 up, so we're going to have 2 down like this. So if I extend this, we got something looking like this. So if we now, well, we want the shape to be half as big from here, so if we've got 2 across and 3 up, in the opposite direction we've got 1 across and 1.5 down, so here's 1 point, and then multiplying the length of the triangle by a half, we get this, and then we go down here somewhere, and then we join these up like so. Okay. So this is our new shape Q. Question number 19. We've got A, B, C, D, which is a rectangle, that's what we see here. And A, E and B are points on the straight line L with equation x plus 2y equals 12. And A and D are points on the straight line M. AE is equal to EB. So this means E is the midpoint of AB, and we have to find an equation for M. Well, if we consider line L, when x equals 0, we would have the corresponding y coordinate being 12 divided by 2, which is 6. So that means that the coordinates of E will be 0, 6. And when y equals 0, we've got x, which is equal to 12. So that means the coordinates of B are 12 across and 0 up. How does this help us? Well, to go from 0 to the 12, I need to add 12. And to go from the 6 to the 0, I need to subtract 6. So going in the opposite direction, I need to, over here, to go from the 0 to the 12, I need to add 12. So in the opposite direction, you can see A has coordinates, x coordinate minus 12, and then 6 to 0, we subtract 6. So in the opposite direction, we need to add 6. 6 plus 6, that's 12. So the coordinates of A are minus 12, 12. Now, how does this help us? Well, what we can also see as well, if we rearrange, we've got y equals minus 1/2 x plus 6. So therefore, the gradient is minus 1/2. So therefore, the perpendicular gradient for line M will be 1 over minus 1/2, which is 2. Let's just write that down for the line M, the perpendicular gradient is equal to positive 2, which is the negative reciprocal of minus a half. And therefore, if we want to find out the coordinates, rather if we want to find out the equation of M, we've got y equals mx plus c, so using y equals mx plus c, we have the y coordinate, which is 12. This is equal to m, which is 2, times by the x coordinate, which is minus 12, plus the c. So we get 12 equals minus 24 plus c, so therefore c is equal to 36. So therefore, the equation of line M, we've got y equals 2x plus 36. We have y equals 2x plus 36. Question 20. The table shows some values of x and y that satisfy the equation y equals a times by the cosine of x plus b. And when x is 0, y is 3. When x is 90, y is 1. And when x is 180, y is minus 1. We have to find the value of y when x is 45. So what we're doing here is applying a transformation to the graph of normal cos x to give this graph here. So if we draw the graph of normal cos x, it looks something like this, and it crosses the, it has a minimum at minus 1 and a maximum at 1. Now here, when x is 0, y is 3, so that's over here. And when x is 180, y is minus 1, so that's over here. And when x is 90, y is 1. So that is over here somewhere. So now if we draw the graph of cos with these values, we have something looking like this time. And when x is 0, y is, rather when x is 120, y is 0. So here we've got 120. So this is the graph of y equals a times by cos x plus b. Well, the 90 over here, for normal cos, the corresponding y coordinate is 0. But for this graph in red, the corresponding y coordinate is 1. So that tells us that the graph has been translated up by 1 unit. And you can see the amplitude here of the graph in red is 4. We're going from minus 1 to 3. So the amplitude rather is 2. Because the amplitude for normal cos is just 1. We're going from 0 to 1. So therefore, by inspection, y is equal to 2 times by cosine of x plus 1. And we want to find the value of y when x is 45. So when x is 45, corresponding y coordinate, we've got 2 times by cosine of 45 plus the 1. So we've got 2 times by, well, cos 45, that's root 2 over 2. And then we add on the 1. And the 2's here to cancel. So we're left with root 2 plus 1. So we've got root 2 plus 1. Question 21, we have to show that 6 minus root 8 over root 2 minus 1 can be written in the form a plus b root 2, where a and b are integers. Well, let's begin with what we've been given. We've been given 6 minus root 8 over root 2 minus 1. And what we would have to do here is multiply both the numerator and the denominator by the conjugate of the denominator. The conjugate of the denominator is root 2 plus 1. So we've got root 2 plus 1, which we have to multiply the top and bottom by. Okay, so now our job now is to work all of this out. So what we've just done here is multiply the top and bottom by root 2 plus 1. So working this out, we have here 6 times by root 2, that's 6 root 2. And then we've got 6 times by 1, that's 6. Then we've got minus root 8 times by root 2, that's minus root 16. And then we've got minus root 8 times by 1, that's minus root 8. Okay. And then on the bottom, we've got root 2 times by root 2, that's just 2. And then we've got minus 1 times by 1, that's minus 1. So now we need to tidy all of this up. So we've got 6 root 2 plus 6, and then minus root 16, well that's just minus 4, and then root 8, that's the same as 2 root 2, so we subtract off 2 root 2. And on the bottom we've got 1. So if we tidy this up even further, you can see we've got 6 root 2 minus 2 root 2, that's 4 root 2. And then 6 minus 4, that's 2. So therefore, this is in the form that's required. You can see A is equal to 2 and B is equal to 4. Question 22. The true triangles are similar in this diagram, and there's 2 possible values of x, and we have to work out each of these values. State any assumptions you make in your working. This question is quite difficult, but let's take the first obvious situation that we see with the 2 triangles. First of all, we've got this situation over here, where this triangle here is similar to this triangle. Here we've got 8 centimeters, and here we've got 12 centimeters. Here, for AC, we've got 8 plus x centimeters, so let's just write that down, x plus 8. And AD, well that's going to be 12 plus 3, which is 15. So you can see these triangles are similar. So, in other words, the corresponding sides will be similar by a scale factor. So for that scale factor, we would have x plus 8 over 8 equals 15 over 12. And if we find out what x is, well, we have x equals, well, x plus 8 equals 15 over 2 times by 8. Sorry, 15 over 12 times by 8, which is 10. So we've got x plus 8 equals 10, and therefore x equals 2. So that's one situation. The second situation is where we swap b and e. So the second situation is this, and this time we have AB, which is 8 over here, so we're just swapping the positions, and then we've got 12 over here. And this time when we talk about the similarity, we're saying x plus 8 over the 12 equals 15 over 8. So if I rearrange over here, we've got x plus 8 equals 22.5, and therefore x is equal to 14.5. So therefore, there's 2 similar triangles which we've spotted. So the assumption is that there are 2 similar triangles, one we see in red and the one we see in blue. Question 23. Here is a rectangle and a right-angled triangle. So the rectangle has dimensions x minus 1 and 3x minus 2, and the triangle has dimensions x and 2x, the measurements are in centimeters, and the area of the rectangle is greater than the area of the triangle, we have to find the set of possible values for x. Well, the area of the rectangle, that will be x minus 1, lots of 3x minus 2. So this here is the area of the rectangle, and this area is greater than the area of the triangle. Now the area of the triangle, that's 1/2 times by the base times by the height, which is 2x. So here the area of the triangle is the result which we see over here. So now if we tidy all this up, on the left hand side we've got 3x squared minus 5x plus 2, and on the right hand side, well, the half and the 2 cancel, so we're left with x squared, and if we simplify this we get 2x squared minus 5x plus 2 being greater than 0. Now we need to solve this. So first of all, let's find the critical values by replacing the inequality sign with an equal sign. So we've got 2x squared minus 5x plus 2 equals 0, and if we factorize this, we've got 2x minus 1 lots of x minus 2 equals 0. So therefore, for our critical values, we've got x is either equal to 1/2 or x is equal to 2. So now we need to state the solutions to our inequality, and if we draw a quick graph to illustrate what we're finding, here is our graph. We've got the 1/2 here and the 2 over here. We've got y here and x here, and we're looking at where the graph is greater than 0. It's greater than 0 here and here. So therefore there's two solutions. We've got x is less than 1/2 and x is greater than 2. Well, if we take a look at the x minus 1, if we have something which is less than 1/2, then we've got, say, 0.4 etc. minus 1, which will always be negative. So let's put that down into words. X minus x being less than 1/2 would result in x minus 1 being less than 0, and because we've got lengths, let's just write this down, but length must be positive, and therefore our only solution is x is greater than 2. So therefore x being greater than 2 is only solution. Okay, so here is our answer. X is greater than 2 is the only solution.